Welcome to Quickly Physics. Today, we will talk about the concept of an ideal gas, as well as about all three of the gas laws that are connected to it. Let's get started. An ideal gas is only a theoretical concept. It doesn't actually exist. Yet, we use it for all calculations for gases, as they come fairly close and it makes those calculations much simpler. For it to actually exist, we would have to have tiny forces between the molecules, which would make them negligible. And the only significant forces that would exist should then be exhibited during a collision. Those collisions would have been between each other as well as the walls, and they would be elastic, which means that all kinetic energy must be preserved and the molecules will recoil in opposite directions. Now, on the concept of an ideal gas, we can explain all three of our gas laws, which are Boyle's law, the pressure law, as well as Charles' law. Firstly, let's look at Boyle's law, which tells us that volume is inversely proportional to pressure, which means that when we decrease volume, we will increase the pressure if the temperature is kept constant. Now, say we have some helium in a confined space, such as a balloon. When we decrease the volume, the molecules will be closer together, they'll have less space to move, and will be colliding more and more with each other and the walls. This will cause them to have more kinetic energy, therefore increase the force. Given that pressure is force over area, increasing the force will also increase the pressure. This lets us deduce that Boyle's law will be pressure 1 times volume 1 being equal to pressure 2 times volume 2. This law can be illustrated with the example of a diver. While he's at the surface, there will be a pressure of around 1 atmosphere acting on him, which is around 101 kilopascal. Now, every 10 meters he descends, the volume of the water above him will increase, and thus also the pressure will increase by 1 atmosphere. The deeper the diver goes, the colder the water will get. Yet, that is due to how much sun can warm it up. However, speaking about temperature, the pressure law relates pressure directly to that. That is when temperature rises and we have a fixed volume, the pressure too will rise. However, before we can look at why this happens, we first need to understand that temperature is basically a measure of kinetic energy. The higher the temperature, the quicker the molecules move. Vice versa, a drop in temperature is a decrease in kinetic energy, and the molecules reach a complete stop at 0 Kelvin, which is around minus 273.15 degrees Celsius. However, that's another story. Let's get back to our pressure law. Here, as temperature increases, so does kinetic energy. This again causes the force of the collisions to increase, thus increasing the pressure. Given that pressure is a constant times temperature, we can compare the two pressures and the two temperatures, giving us the formula of pressure 1 over temperature 1 being equal to pressure 2 over temperature 2. This experiment can be observed by placing an empty bottle into the freezer. Once the temperature falls, the volume is remaining constant. However, because the temperature inside the bottle is now less, the pressure of the air will also decrease. This will cause the bottle to compress. Last, but definitely not least, we have another law that looks at the temperature, yet this time compares it to volume. Which as you may have figured, volume this is directly proportional to temperature, Charles' law, which means that when we decrease the temperature, the volume will also decrease. This can again be understood by the decrease in kinetic energy, which will cause less force to be acted on the walls, therefore decreasing the pressure, and also causing the molecules to not push off of each other as much, therefore decreasing the volume. This can be beautifully observed with a balloon filled with normal breathable air. Say we take that balloon and pour some liquid nitrogen, which is very, very, very cold over it. Now, the air inside of the balloon will start to cool down and the balloon will start to decrease in size. With this, we're coming to an end of our video. Check back soon to learn more physical concepts very quickly.